Today, we're going to talk about something that could completely overhaul the air conditioners we all rely on every day. We're looking at research that's making them smarter, way more efficient, and a whole lot better for the planet.
Yeah, I know. It sounds like a pretty huge claim for that box humming in your window. But believe it or not, the cooling systems in our homes and offices are at a massive turning point, and it all starts with their surprisingly high environmental price tag.
So, first things first, let's really wrap our heads around the problem, because the simple act of staying cool, well, it comes at a cost, a really big one.
Look, these systems are absolute power hogs. They are major players in how much energy we use and how many greenhouse gases we pump into the atmosphere. We're not talking about a tiny sliver here. It's a huge piece of the climate change pie.
A huge part of the problem comes down to the chemicals inside them, these things called hydrofluorocarbons, or HFCs. They are incredibly potent greenhouse gases. In fact, the whole world is now trying to phase them out through international agreements, and that's forcing the entire industry to find cleaner, better alternatives. But just swapping out a chemical isn't enough. You need a whole new way of thinking.
Right, so you're probably thinking, just find a new chemical. What's the big deal? Well, it's not that simple, not even close. It actually creates this massive, almost impossible puzzle for the engineers who design these things.
And right at the very heart of that puzzle is something called compression architecture. The easiest way to think about it is like the engine of your car or the heart in your body. Its design controls literally everything. How much power the AC uses, how well it actually cools your room, and how long it's going to last before it breaks down.
And this is where it gets just wildly complicated. An engineer has to perform this incredible balancing act. I mean, you want it to be super energy efficient, right? But it also has to be reliable. And it needs to have a tiny environmental footprint, but it also has to be affordable and easy to build and easy to service. Oh, and it has to work perfectly for the specific climate it's in. Juggling all of that at once, it's a true designer's dilemma.
So, how in the world do you solve a puzzle that seems impossible? Well, you don't. You build an intelligent tool to solve it for you. And that is the genius at the core of this research. The solution is this master plan, all wrapped up in a super sophisticated algorithm. You can think of it as an intelligent architect that systematically chews through all those competing factors to find the one single best design for any situation you can throw at it.
And when I say it considers everything, I mean everything. It looks at what the user actually needs, pulls in local climate data, checks what parts are even available, and, this is the crucial part, it calculates the total environmental impact of the system over its entire life.
Okay, so let's peek under the hood and see how this intelligent architect actually works. How does it sift through thousands of possibilities to find that one perfect champion?
The whole thing basically boils down to a four-step process. First, it generates every single possible design that could work. Then it simulates each one to figure out its energy use. After that, it gives each design a score for how practical it is to actually build and maintain. And finally, it calculates the total climate impact from cradle to grave.
So in that first step, the algorithm just goes wild, brainstorming this enormous list of potential candidate designs. But then, for step 2, it gets really serious. It puts every single one of those candidates through a tough simulation, using local weather data to see how much power it would actually use in the real world.
Now, these next two steps are what make this tool a total game changer. It scores each design on something called constructability, which is basically a fancy way of asking, how much of a headache is this thing to build, keep safe, and fix? Then it calculates its life cycle climate performance, or LCCP. And that's the big one, the total environmental footprint, from the factory emissions all the way to refrigerant leaks and what happens when you throw it away.
So at the end of the day, every single potential design gets judged on these three critical things. How much energy does it guzzle? How practical is it to actually build and own? And what is its total, absolute lifetime impact on our climate?
And now for the magic trick. In the final step, an AI-powered optimizer takes those three scores, weighs them all against each other, and pinpoints the one single design that hits that perfect sweet spot of performance, practicality, and sustainability. That is the champion architecture.
You know, the implications here are so much bigger than just a better air conditioner. This is really about a fundamental shift in how we approach complex engineering problems, period.
As one of the researchers, NSIERRA, puts it, the goal here is to pave the way for the next generation of environmentally responsible and technologically advanced technologies. This tool is basically the roadmap to get us there.
Ultimately, the big takeaway is this.
We are looking at a future where we don't have to guess or make compromises anymore. We can use data and AI to make these incredibly complex engineering decisions that are optimized not just for money or for raw power, but for the long-term health of our planet. It's about making things sustainable by design.
And that leaves us with a really powerful final thought to chew on. What would our world look like if every complex machine we build, starting with the humble AC unit, was perfectly and intelligently designed for both its user and for our shared planet? Pretty cool thing to think about. Thanks for tuning in.